I'm a professor of philosophy at Fordham University in New York City. I work in the philosophy of mind and language and formal semantics. And also I have a historical interest in scholastic philosophy, metaphysics, and logic and philosophy of language, the relevance of which I hope will turn out from the presentation itself, which is not really paper, properly speaking, but as you can see from the abstract, it is a multidisciplinary project proposal submitted in the hopes that it may garner enough interest to launch it with members of the AI, artificial intelligence research community, along with linguists and philosophers of mind and language interested in constructing a semantics for natural logic for artificial intelligence. The paper outlines some of the major hurdles in the way of a semantics-driven natural language processing system based on standard predicate logic, and sketches out the steps to be taken toward a natural logic, a semantic system explicitly defined on a well-regimented but indefinitely expandable fragment of a natural language that can therefore be intelligently processed by computers using the semantic representations of the phrases of the fragment. So it's pretty much building up a knowledge base that can be used for further computer processing, but defined directly on a natural language database. So the purpose of this proposal is to launch a research project facilitating intelligent natural language processing by computers. In order to do so, we intend to pool the resources of scholars working in various fields, ranging from linguistics, philosophy, and history of logic, as well as model theoretical semantics and formal ontology, to computer science and artificial intelligence, cognitive psychology, and even ethics, as you'll see toward the end of this presentation. The need for such wide-ranging collaboration becomes apparent once we consider the enormity of the task. Now, to make computers intelligent, at least to the extent of being capable of processing bits and pieces of a human language with some semblance of understanding, we need to understand what the intelligent use of language consists in. For of course, linguistic symbols can be used, processed, and manipulated without any understanding whatsoever, as it happens in simple word processors. Indeed, through the interactions of an intelligent user, even such primitive symbol manipulators can produce useful results, such as neat formatting, spell checking, or answering simple questions about text, or even an enormous number of documents through string searches and other mere syntax-oriented queries, without any representation of the meanings of these symbols in the machine doing the language processing itself. By contrast, the holy grail of intelligent language processing would be the ability for the machine itself to process linguistic symbols with a semblance of understanding to do the processing regarding the meanings of the symbols being processed. This is what we can refer to as semantics-driven language processing that we humans do when we use language with understanding. The proposed project will address this intuitive idea of intelligent language use through tackling the conceptual and practical issues involved in understanding how natural language processing works for us humans, the natural users of our natural languages, as the medium of human thought, understanding, and reasoning, and the applicability of the lessons learned from this study to artificial intelligence in computer science. Therefore, the two tasks indicated in the title of this project do require such broad-based collaboration. Dealing with natural logic and artificial intelligence necessitates the recruitment of scholars from the wide range of fields indicated above. Now, logic, as taught and practiced today as an academic discipline in the Frege-Russell tradition, is still primarily a formal mathematical study of certain fundamental forms of reasoning whose validity hinges on the fixed meanings of so-called logical constants or logical connectives, such as those expressed by our language's syncagrammatic terms like and, or, if, then, not, some, or every, which provide the formal structure of various forms of valid reasoning about any time of material expressed by our categorematic terms, namely the terms that function as the subject or predicate of our categorical propositions. However, classical formal logic, that is standard predicate logic, is known to diverge from natural languages on various levels. First, there is a known mismatch between the syntax of predicate logic and natural languages, based on predicate logic's treatment of all common categorematic terms as predicates, hence the name predicate logic, of singular referring expressions, individual names and variables meant to represent proper nouns and pronouns of natural languages, respectively. Accordingly, predicate logic does not acknowledge the role of common terms in their referring function, forcing a reinterpretation of simple categorical propositions as conditionals or conjunctions, or leading to mere bewilderment over certain so-called pleonastic phrases. For example, on this approach, some or all or most Greeks are mortal would turn into some X is a Greek and X is mortal, and every X is such that if X is a Greek, then X is mortal. And just a source of embarrassment in the last case with most, because there is provably no adequate representation of most Greeks are mortal in standard predicate logic. But and that is why it is also a motivation for the so-called generalized quantification theory. Now, here are the references that deal with these phenomena. Besides this well-known mismatch in syntax, there is also the known fact that there are various valid forms of reasoning not captured by the notion of logical validity defined for the formal language of predicate logic, namely those forms of reasoning whose validity is based on the information content of the categorematic terms of our propositions, which is precisely what is disregarded by the formal language. For instance, the page you are reading is in front of you, therefore it is not behind you. Or it is white, therefore it is not black. These are perfectly valid inferences, the validity of which, however, is not captured by standard predicate logic. But this is precisely the kind of scenario which these knowledge graphs can handle. A little more on this a little bit later. So I think Jane's project would be highly relevant to processing databases and producing language graphs, which can serve as the grounds for such so-called materially valid inferences. Now, but there are also obviously invalid forms of reasoning, which, however, based on their syntactical form alone, would appear to be instances of formally valid patterns. For instance, whatever is healthy is alive, but the food in this health food store is healthy, therefore it is alive, which is invalid because of the equivocation of healthy in the premises. In the first premise, healthy means something in good health is alive, and in the second, the healthy food in the food store is something that causes good health, but is not necessarily in good health itself, right? Now, this divergence between the notion of formal validity of a formal system and validity of actual pieces of natural language reasoning is nothing new. In fact, Aristotle, the father of logic, recognized that his formal system of syllogistic reasoning did not capture all valid forms of reasoning, which is why he wrote the topics, not surprisingly, in connection with the categories. Basically, Aristotle's categories is this knowledge graph system consisting of Porphyrian trees that is the basis for the immediate inferences of the topics to deal with valid non-syllogistic reasoning. And Aristotle also recognized that there were many invalid forms of reasoning appearing to fit into valid syllogistic patterns, which is why he wrote his sophistical refutations, cataloging various forms of fallacious reasoning. It was also the realization of this divergence that motivated scholastic logicians' sophisticated discussions of the notions of logical consequence, striving to provide a unified account of valid reasoning in a regimented, explicitly regulated version of academic Latin. But over the course of history's twists and turns, the scholastics' achievements were nearly completely forgotten and were in modern times superseded by the theory and practice of formal logic as we know it, yielding classical predicate logic and its intentional versions in Montague semantics, etc. Now, considerations of this sort recently more and more often prompted the expressed need for a natural logic, both among philosophers of language and among computer scientists. A natural logic, in the requisite sense, would be a formal semantic system for a well-regimented fragment of a natural language with explicit phrase structure rules for its syntax and a recursively defined model for its semantics. For an early attempt, you can see a paper dealing with this type of system and presenting this type of system. What would make this approach natural in the first place would be cutting out the intermediary of a formal language along with its translation rules in the vein of Montague semantics from the well-regimented fragment of natural language. In the second place, its semantics would allow the model theoretical definition of a categorical structure, much in the vein of the Aristotelian theory of categories, licensing formal inferences based on the formal relations among the semantic contents of its categorematic terms, much in the vein of the loci of the Aristotelian topics. Indeed, the compositional semantics for its propositions would enable the system to construct the semantic content of its propositions, thereby allowing for a content-sensitive definition of valid inference based on the idea of the containment of the semantic content of the conclusion and the semantic content of the premises, along the lines of the conception of the via antiqua tradition of scholastic logic, yielding irrelevant logic without the so-called paradoxes of entailment. Now, the recursive formulation of the formal semantics will allow the computability of the semantic values of any complex phrases for any arbitrarily chosen ontology. Hence, the system should easily offer itself for artificial intelligence, enabling the computer to see the implications of all well-formed sets of sentences, which can actually be simply grammatical sentences of a natural language, thereby getting really close to intelligent natural language processing. Approaching the natural logic in question from the starting point of standard predicate logic, the following steps need to be taken. Represent a noun phrase with a restricted variable, the values of which come out of the extension of the noun phrase, provided it is not empty. Otherwise, its value is a zero entity outside the universe of discourse. For example, all humans are mortal will become every X that is a human is mortal, where the values of X that is a man will be elements of the extension of the open sentence X is human, provided it is not empty, otherwise it is zero, an arbitrary item outside the universe of discourse. The advantages of this approach include overcoming the mismatch of syntax mentioned above As you can see, this is much like a categorical formula as opposed to the conditional or hypothetical formula applied in standard predicate logic. And as a result, we could restore the full traditional square of opposition and syllogistic and the immediate access to generalized quantification theory without the ontological extravaganzas of generalized quantification theory. So here, instead of all humans are mortal, we could just have most humans are mortal, without trying to find the relevant propositional connective that people were searching for in vain, obviously in standard predicate logic. Now, a game theoretical model for this approach, as well as its perfect match with scholastic logic, has already been presented in a paper I published together with a colleague of mine at Helsinki University way back in 1990. Now, next step, provide a tensed modalized version of the previous system in which the tense and modal operators in the matrices of restricted variables can perfectly model what scholastic logicians call the ampliation of terms, the phenomenon that in these intentional contexts, such as tense contexts and modalities, in modal contexts, such as can, possibly, necessarily, etc. In such contexts, the range of reference of our common terms becomes extended beyond actual existence, allowing quantification over and reference to non-existence. For example, every horse is alive, no that horse is alive, and therefore no that horse is a horse. However, whatever is that F was an F and was alive, therefore that horse was a horse and was alive. So we can actually tease out these immediate inferences in this type of logical system. The advantages of this approach should be obvious to anyone who considers how ampliation in natural languages works. Next step, number 3, define a signification function inspired by a paper by Peter Geach as the semantic function of predicates in a model that contains at least actual and non-actual elements in the domain of discourse in this way. The significate of the predicate P in U is an element of the domain. The simple predication Px is true relative to a value assignment F, just in case the significant of P in f of x is an element of the actual part of the domain, where f of x is the value of x in an evaluation f. For example, Socrates is wise will be true just in case the significant of the predicate wise in the value of the name Socrates, that is Socrates himself, is an element of the actual part of the domain, that is just in case Socrates' wisdom is actual. This is what medievalists refer to as the Scholastics' Inherence theory of predication, the idea that the truth maker of a simple predication is the actuality of the individualized properties signified by the predicate in the individuals referred to by the subject. So this will require a peculiar ontology involving individuals, their individualized properties, as well as the universal properties that are instantiated by these individualized properties. One immediate advantage of this approach is that it yields very fine-grained intensions, even for logically equivalent predicates. Take, for instance, the signification function of the term triangular does not have to be the same as the signification function of the term trilateral, despite their equivalence. triangular, and trilateral are necessarily equivalent phrases, right? Necessarily equivalent coextensive predicates, yet they are non-synonymous. And so this then can be cashed out in intentional, with a T, psychological contexts. For example, John knows that a circle is a circle, yet he doesn't know that a circle is the locus of points equidistant from a given point, since he has no concept of a geometrical locus. So these are further refinements of the system that can be applied also to such psychological contexts. Finally, choose a manageable, regimented fragment of a natural language and apply the semantic ideas listed above, including a categorization of its categorematic terms, allowing for topical inferences based on the signification of the categorematic terms, as well as on the syncagrammatic structure of its propositions. To that end, define propositional signification compositionally and allow mapping all semantic values of all your phrases onto a categorially structured ontology, as outlined in the paper referred at number 9. So the rest is just a matter of depth programming. That is where you computer guys would come in. And then you can have a machine that will understand your regimented linguistic fragment insofar as it will have a semantic representation of a potential infinity of phrases generable in your fragment, and will therefore intelligently converse about the issues expressible in your fragment. The fragment can, of course, grow and cannibalize ever larger portions of a natural language, indeed several natural languages, allowing for more intelligent translations than any syntax-driven systems can produce. Now, so this would be the rough outline of the project. What would be the methodology? To be able to test whether we are moving in the right direction, we need to start small. We should start out with a small vocabulary and a very restricted set of construction and interpretational rules, so we can see with our finite human intuitions that the rules we input into the machines do indeed produce the intuitively correct results. Still, we must do this with a view to the further ends. As should be clear from the foregoing, the natural logic to be taught to computers requires a well-regulated, regimented language in which the terms themselves bear their contents on their sleeves, namely, they carry essential information about the things they name. That is precisely the scenario, for instance, in organic chemistry or also in inorganic chemistry, where the strictly regulated nomenclature serves exactly this purpose. But we can just deal with apparently any data sets, as again, Jane's wonderful presentation illustrated on Yelp database. So if we produce these knowledge graphs, then we can have the topical inferences built into the system immediately. So taking some basic samples of texts in this field, we should first see if the results produced by the machine would fit our intuitive expectations. And whenever we find some anomalies, we need to chisel our rules accordingly. However, this trial and error period can be significantly shortened, and the whole enterprise can be substantially broadened by the input of our colleagues working in the fields listed above. So the entire project needs to be given a more definite shape through a launch event where our collaborators can pitch in with their ideas from their fields of expertise. So, and coming to the risks of benefits, I promised to reflect on this aspect of the project as well. What if the production of genuinely intelligent language-using robots, as opposed to the glorified word processors of today, becomes a reality? On the one hand, the exponential growth of the processing and storage capacities of today's computers and the similarly exponential growth of scientific data make it virtually impossible for our individual human intellects to keep pace with the explosion of scientific information. So intelligent computers may soon surpass humans in many fields, especially those involving long and boring tasks that humans would not and or could not tackle, while robots would handle with ease and without complaints. So much for the benefits. On the other hand, the potential for humans being surpassed by robots in areas requiring intelligence immediately raises the specter of well-worn staple of sci-fi, the killer bots. The usual sci-fi way to face these potential risks is to require the implementation of some safety measures. Think Asimov's laws of robotics. And the plot usually unravels to show the ways in which those safety measures can be overridden by evil humans or can go awry through misinterpretation of their intent by merely robotically intelligent robots. The novel approach of this project would be based on the insight that intelligence and benevolence are not incompatible. Indeed, on the contrary, ideally they would go together. But if artificial intelligence is the artificial implementation of the ideals of human intelligence, then it should be the implementation not only of the theoretical intellectual ideals, flawless calculation and reasoning, but also of the moral ideals acting for the perfection of humanity in each individual and all mankind. Thus, one of the tasks of this project will also be the articulation of these ideals, along with the means of their implementation. Accordingly, the launch event should be a workshop of invited participants who can provide their input concerning the requisite tasks and subtasks of the project. Who will oversee the fragment of a natural language, English, to be processed? Who will work on its semantics? What type of semantics should it be? What sort of ontology would it require? What sorts of categories will it include? What will be the basis of the categorization? What types of inference rules will the semantics license besides those licensed by the sync-agrammatic structure? What are the topical rules of inference we can use from scholastic logic? How shall we treat fallacious forms of reasoning that scientific texts are obviously not immune to? What are the expectable risks and benefits, even in the early stages of the project? In what ways will the resulting artificial intelligence be different from human intelligence? And what are the potential security and ethical issues emerging from them? This is just a somewhat random sampling of the theoretical and practical questions such a workshop will have to address. And the concluding section of the paper presents suggested topic list for the workshop: natural logics, their semantics, proof systems, and computational feasibility, the development of natural logics, the Aristotelian and medieval logical tradition, etc. Just a little overview of the history of logic, natural logic as extended syllogistic logics, natural reasoning and domain-specific reasoning, for example, handling of plurals and parthenomies, natural logics and diagrammatic logics, relationships between natural logics and natural languages in the plural. That is not, obviously we are all using English most of the time, but that is not the only natural language that needs to be considered. Semantic issues such as intentionality and collective versus distributive readings and natural logic for knowledge bases, and artificial intelligence systems, formal ontology and category theory, categories and topical reasoning in natural logic, connections between natural logics and description logics, security and ethical issues related to the emergence of intelligent robots. Now, as will be clear from this little closing acknowledgement section, the idea of this workshop came up in collaboration with a Danish group of computer scientists working with Jørn Fischer Nielsen, who generously invited me for a discussion of plans outlined, the plans outlined above in 2018. But for various practical reasons, the workshop did not materialize in the year we planned it for. So this is just my attempt to revive what still appears to me a worthy idea. Question is if there are any takers coming out of this workshop. Thank you very much.